Hello, and welcome to part 1 of this series about designing, testing and building a control and monitoring system for our self-built motorhome. Please subscribe and hit the bell to get updates of future videos in this series. The first job I had to do was choose which microcontroller to use. Due to its popularity and massive global user base, the Arduino was my obvious choice. There are thousands of examples on the internet, and almost all functions I need have already been done in several different ways. The functions I require from the controller are a fresh water tank level indicator with an alarm when the water level gets low, a wastewater tank level indicator, and again an alarm for when it gets full. Being able to measure the water temperature is another feature I want, and this can warn me if the water is close to freezing. Future plans include tank heaters to stop the water from freezing, which will come on automatically when the water temperature gets to a certain point. Inside and outside temperature sensors. Battery meters for the leisure batteries and truck batteries. I also hope to incorporate controls for a battery charger too. Water pump control. This is to enable or disable the water pump. For example, when the fresh water tank is empty or the water is close to freezing, the pump can be disabled to prevent it being damaged. Time and date are another feature that is easy to incorporate with an Arduino. I also want to be able to control the rear steps and get warnings if they are unsafe to raise or lower. Wastewater dump can be controlled using the touchscreen via the Arduino to a 12-volt solenoid valve. A winterize mode adds more solenoid valves to dump water from the fresh tank and also drain the internal plumbing to prevent frost damage during storage. Another thing I want to control is the lights. This isn't essential, but I do plan on making a phone app so lights can be turned on or off when you're in bed. The Arduino Mega I'm using has 54 digital input or output pins. 15 of them can be used for pulse width modulation. PWM is a digital way to vary the amount of power going to a device. This can be used for things like dimming lights or varying fan speeds. It also has 16 analog input pins, which can be used to measure voltage or resistance via the computer's onboard analog to digital converter. The input voltage will be connected through a power supply unit to keep the Arduino safe from voltage spikes. The touchscreen I've gone with is a Nextion 3.2-inch advanced screen. It has a serial interface with the Arduino, which frees up a lot of pins compared with other LCD screens. It has a built-in real-time clock which can be programmed to give accurate date and timekeeping. The firmware I make for the screen can be uploaded via microSD card, which means it doesn't need connecting to a computer to make changes. Nextion also supply a free graphic interface editing software, which enables us to add some pretty nifty features to the screen. It also has the ability to send and receive data from the Arduino over its serial connection. I started off sketching some of the inputs and outputs I want on the Arduino. First off, a water level sensor and temperature sensor in the freshwater tank. For the waste tank, I've opted for 5 float switches, which are more suited to dirty water conditions. These are set at 20, 40, 60, 80 and 100% marks. The touchscreen, of course. I also have the main lighting split into 2 circuits, front and rear. I want switches at the rear of the truck near the habitation door to control both circuits, and switches at the front. Push button switches mean I can have the Arduino switch a pair of relays for each circuit every time a switch is pressed. The steps have a few more options, so I'll cover the step circuitry separately. I also need 3 more relays, one to control the water pump, one for the wastewater dump solenoid, and another one which will open solenoid valves to dump all the water from the plumbing system. The Arduino also needs a power supply to protect it from spikes in the input voltage from the batteries. I also want to fit a Bluetooth module so I can make a phone app and control all these functions on that too. As the Arduino inputs are limited to 5 volts, a voltage divider circuit is needed to monitor the battery levels. I will need 2 of these, one for the 12 volt leisure batteries and one for the 24 volt truck batteries. The steps are stored folded in for travelling and are currently pulled out by hand. When you're inside the truck, you don't have a way of lowering or raising them, so I want to fit a pneumatic actuator powered from the truck's air supply. As the actuator could potentially cause damage to nearby objects or people, I want to fit an ultrasonic sensor, like a car's reversing sensor, to warn and prevent the steps lowering if there is an obstacle in the way. I'm also going to fit a switch so the Arduino knows when the steps are fully up. I also have the same issue of someone potentially being on the step and the raise button pressed, so I will fit another sensor on the top step to detect if anyone is on the steps when it is being raised. As I'm not very good with image editing software, for these test screens I'm using some simple backgrounds to get me started. I first chose a simple blue royalty-free image for the background. Next I needed some icons to go onto the screen. Again, these are royalty-free icons and I chose a few simple icons for the functions I need. These are light bulb, water, battery, climate control, steps and settings. I next use Pixlr to place the icons on the background. Later on I can place touch hotspots over these areas to use them like buttons on the screen. I placed all the icons roughly where I wanted them, as the final version will be done with correct sizing and spacing. As long as the icons are in roughly the right area, changing the background image doesn't affect the coding of the screen. I next save the image as a PNG file to upload to the Nextgene editor. I open a new project, choose the screen I'm using and the orientation I want the screen to be in. Next I add the home screen image to the Nextgene editor and set it as the background picture. The picture here is a slightly later version of the home screen with text at the top for level gauges. I add hotspots over the areas I want to touch to access that feature, and set each one as a touch release event. I add 6 more pages for each of the menu items and rename them to make things easier to navigate. You can now see I've added 3 progress bars at the top for the water and battery levels and renamed the touch areas. Again, this is just to make it easier to remember which one does what. The Nextgene editor has a debug feature which simulates how the program works in the real world. I've added some buttons for the lights and some extra menus. For the steps, I've added a dual state switch which changes the direction of the arrow depending on if the steps are up or down. The status at the bottom will display if the steps are up, lowering, down or raising, depending on the state of the limit switches on the steps. For the level gauges, I can send commands from the Arduino to change what the screen displays. So if I set the fresh water value to 90, the bar moves to 90%. The same for the wastewater and battery bars. In the water menu, I've made the same progress bars, but larger and with numerical indications too. I can send the same numerical data I send to the progress bars to these numbers to display their values. There is also a wastewater dump button which will send a command to the Arduino to energise the wastewater solenoid relay and open the tank. So that's all for this video. In the next episode I'll be making the circuits for the water level indicators and writing the code to send these values to the screen. Please subscribe and hit the bell to be notified when the next episode is released. And thank you for watching.